Hiya Joe, this is your feedback video for the Circular Motion 2 homework. So starting with question 1, label the forces acting on the car in each situation. This is good, good, good. Yeah, well done. You're the only person who's got this completely right. Good start. Okay. The only person I've marked so far. I've got one person left to mark, so we'll see. But yeah, this is really good. What are the possible origins of the centripetal force on the car in figure 2? As the car is slanted, a component of the weight acts toward the center. That's not actually true, okay? Look at the weight. The weight does not have any horizontal component. The weight is a vertical force, right? So, you know, it does not have a horizontal component, so that's not correct, okay? This can be found by this. No, this isn't right, I'm afraid, Joe. No, okay. I'm gonna just give you a tip here. Look at the reaction force and let me just draw in the vertical. And we'll call this angle here theta. The reaction force has a horizontal component that acts toward the center of the circle, given by, well, it would be r sine theta. The friction force, if I draw in the horizontal, that angle there is also theta. The frictional force has a horizontal component, which would be f sine theta. No, f cos theta. It would be f cos theta. Anyway, you don't even need to go into that kind of depth. The point is, both the reaction force and the friction force have a horizontal component, and it's the sum of those two horizontal components which provide the centripetal force. Okay, so I want you to put all of that into writing, please, here. This looks correct. Let me just double check. Yeah, 7.1, well done. Okay, question 2. This is good. That's correct. That's correct. Yeah, this is correct. Well done. So full marks for question 2. Question 3. So the van going over the humpback bridge with a parcel. This is interesting. You've been asked to label the forces that act on the parcel as it goes over the highest point of the bridge. Now, you're right, there are two forces only, weight and reaction force, but why have you offset these arrows? If you think about it, if this were true, if these forces acted along different lines, then the parcel would rotate. These would actually produce a torque on the parcel and make it rotate. It would be this way, wouldn't it? So you have to make them along the same line. Okay, so this isn't right, I'm afraid. This is correct. Good. This is correct. What would happen to the magnitude of the reaction force if the van passes over the bridge with a higher velocity? Okay, magnitude of R would decrease. That's correct. You need to explain why. You haven't said why. So what you need to do here is you need to reference this equation. Think about the terms on the right hand side. mg is a fixed number, that's the weight of the package, that doesn't change, but this term here will increase when v increases, which means that your answer for r will decrease. So you need to put that into writing. Okay, that's how you get one of your marks here. Then you need to talk about the significance of this particular speed. That's right. This is interesting. You've correctly said that if you exceed the speed, the parcel will lift off the floor of the van. That's true, but this is not the right answer, as r would become greater than mg. No, that's not true. R would become 0. I think what you mean, you don't mean r would become greater than mg. You mean this term here, mv squared over r would become greater than mg. Basically, at around 15 meters per second, this term becomes equal to mg. In other words, r becomes 0. That's the key thing. R becomes 0, and that's the point when the parcel lifts off the floor of the van. So you need to do a bit of work on this answer here. I'm not sure if you can get a mark for this bit because anyway, yeah. But okay, next, this is correct. Good. This is right, but for some reason you've rounded it off to 1 SF. You need 2 sig fig. So you know, 2.0. I think the answer is 2.01 hertz, so 2.0 is fine, but I can only give you 1 mark for that. This here, yeah, a bit disappointed that you haven't had a go at this, really. This is too vague. You can't get a mark for that. We're going to go through this in the lesson, but yeah, I would have expected you to at least have a stab at this. Okay, but so other than this, there's a couple of other bits that you need to tweak. Calculations are good. It's just some of the wordy questions need some work. Okay, if you have any questions, just let me know in the lesson.